We are about to rationalize the numerator of a radical expression. If you did not cover that, then make sure you skip over this problem. Let's look at the following expression. Here is my expression, and we'd like to rationalize the numerator of this expression. Now, rationalizing the numerator simply means we want to write this as an equivalent expression, but without a radical in the numerator. And we do this the same way as for rationalizing the denominator. I will rewrite this. It's the square root of 6 plus x all over 8. Study the numerator. You can think of this as a binomial. And to rationalize the numerator, then we multiply numerator and denominator by the conjugate of the numerator. So we will multiply by the conjugate. What's the conjugate of this square root of 6 plus x? It's square root of 6 minus x. If I multiply the numerator by this factor, I must multiply the denominator by that exact same factor also. And now let's see what we have. In the numerator, think of this as maybe a binomial times a binomial, so you can multiply using the FOIL order. Square root of 6 times square root of 6 is 6. The product of the outside terms, that's minus square root of 6x. Product of the inside terms plus either x square root of 6 or square root of 6x, either way. And then last times last, that's minus x squared. By the way, this x and this x, they are not under the radical. So you can write it as x square root of 6 or square root of 6 times x. Remember, multiplication is still commutative and associative. And then I have in the denominator still 8 times square root of 6 minus x. So what do we have in the numerator? The middle terms subtract out, and I have 6 minus x squared, and I'll go ahead and leave it in factored form in the denominator. So that's 8 times square root of 6 minus x. Whether you multiply it or not, it makes no difference, but I'll just leave it in factored form. Notice I have rationalized the numerator.